All right, welcome to the Explainer. Today we're doing something, well, something huge. We are going way, way back in time to build our entire solar system right from scratch.
I mean, seriously, have you ever just looked up at the night sky and thought, how? How did all of this, our sun, our Earth, all the planets, get here? It's maybe the greatest origin story of all, and today, we're going to put the pieces together.
Okay, so to get our heads around this, let's treat it like a giant cosmic mystery. And like any good detective, the first thing you have to do is gather the clues. And believe me, our solar system has left behind some pretty big ones.
So, any theory that wants to be taken seriously has got to explain these four things. First, this incredible, orderly motion we see. I mean, everything orbits in the same direction, almost on a perfect flat plane, kind of like cars on a racetrack. Second, you've got two completely different kinds of planets, the little rocky ones close to the sun and the huge gassy ones way out there. Third, what about all the leftover stuff? You know, the asteroids and comets. And finally, you have the weirdos, the exceptions that seem to break all the rules.
So, we've got our clues. Now it's time to line up the suspects, the scientific theories that try to explain how it all went down.
For a long time, there were really two main ideas on the table. One was the close encounter theory. The idea was that some other star zipped past our sun and literally ripped a bunch of material off it, and that stuff became the planets. But, that theory had a lot of holes. It just couldn't explain the clues, especially why everything moves so neatly. So, that leaves us with our prime suspect, the Nebular Theory.
Now, this idea has actually been around for over 200 years. The Nebular Theory says our whole solar system was born from this gigantic spinning cloud of gas and dust, the solar nebula, that collapsed under its own gravity. And what's amazing is that today we have an incredible amount of evidence backing this up.
So, here's the big question. Can our prime suspect, the Nebular Theory, actually solve all four of our clues? Let's put it to the test. First up, that super orderly flat motion.
To crack that first clue, we have to talk about a fundamental law of physics, one that applies to literally anything that spins. See, as that huge cloud of gas and dust started to collapse in on itself, something pretty amazing started to happen.
It started spinning faster and faster. The best way to picture this is to think of an ice skater. You've seen this, right? When they pull their arms in tight, their spin just goes crazy fast. The solar nebula did the exact same thing. It's a perfect example of what physicists call the conservation of angular momentum.
And this spinning is the key to why everything is so flat. As this cloud was spinning like crazy, all the little particles inside were constantly bumping into each other. These collisions basically canceled out all the random up and down motions. It averaged everything out, forcing the whole cloud to flatten into a rotating disk, a protoplanetary disk. And since the planets were born inside this disk, they inherited its flat, orderly motion. Boom! Clue number one solved.
Okay, but that brings us to clue number 2. Why on Earth are there two totally different types of planets? Why are the inner worlds all small and rocky, while the outer worlds are these massive gas giants?
The answer boils down to one simple but really important idea: the frost line. Think of it as a dividing line in space. Close to the young, hot sun, it was just too warm for things like water to freeze, so only materials with super high melting points, like rock and metal, could become solid. But farther out, beyond this frost line, it was cold enough for ices, water, methane, ammonia to form.
And this table just lays it out perfectly, right? Inside the frost line, all you had to build with was rock and metal. There just wasn't that much of it, which is why the terrestrial planets like Earth are relatively small. But outside the line, whoa, you had rock, metal, and a ton of ice. All this extra material allowed the outer planets to get huge. So big, in fact, that their gravity was powerful enough to suck in and hold on to all the hydrogen and helium gas floating around in the nebula.
So how do you actually build a planet with this stuff? The process is called accretion. It really starts small with tiny little dust grains just sticking together. Then those clumps collide and stick, forming bigger clumps, eventually creating things we call planetesimals. They're like the building blocks of planets. And over millions of years of more and more collisions, these things grew into the planets we know and love today.
And what's so cool is that this one theory neatly solves our last two clues. Those asteroids and comets? They're just the leftover planetesimals, the construction debris that never made it into a planet. The rocky asteroids are the leftovers from inside the frost line, and the icy comets from outside. And the exceptions? Uranus spinning on its side or our own giant moon? Those are the scars of a really chaotic and violent final stage of planet building. A massive impact probably knocked Uranus over, and another giant collision is the best theory we have for how our moon formed.
Okay, so our theory checks out. It explains all the evidence. But every good detective knows you need to establish a timeline. So when did all this happen? How can we possibly know how old our solar system is?
Well, we have this amazing tool called radiometric dating. It works because some elements are naturally radioactive, which means they decay into other elements at a perfectly steady, predictable rate. It's like a cosmic clock. By measuring the ratio of the original element to the stuff it decayed into inside a rock, scientists can calculate exactly when that rock first formed.
And when we use this technique on the oldest things we can get our hands on, meteorites, which are basically pristine leftovers from that original nebula, they all point to the exact same age. We know with incredible precision that our solar system was born about 4.5 billion years ago.
So, we've cracked the case. We've got a theory that fits all the clues, and we've got a timeline. And this all leads to one last, really fascinating question about our own little corner of the universe.
You see, the basic laws of physics mean that planet formation is probably a super common thing. Whenever a star forms, a disk is likely to form around it. Frost lines appear, and planets get built. It's probably happening all over the galaxy right now. But the specific details of our solar system, the number of planets we have, their exact sizes, their orbits, those giant chance collisions, that was all down to random chance.
Which leaves us with this pretty profound thought. Was our solar system a cosmic accident? Well, having planets might be the rule in the universe. A system that looks exactly like ours, one with a planet like Earth, with life, at just the right spot, well, that might be the result of a very specific, and maybe very rare, series of cosmic flukes. Definitely something to think about the next time you look up at the stars.